Jane L. And I am from the Group 5. Our title is Concept of System Linear Inequalities, and our theme is solving the system of linear inequalities to its graphing solution. And our objective is first is to analyze the full concept of the system of linear inequalities, and the second is to understand the step-by-step procedures of finding the solution of the system of linear inequalities. And the third one is to determine the overlapping region where the solutions to an inequalities are exist. So our introduction, the system of linear inequalities are used to model scenarios with multiple constraints. So, for example, you're buying snacks for a party and you want to buy enough so you don't run out. Snack is greater than or equal to what people will eat. But also, you don't want to overspend your money spent on snacks. Is less than or equal to the budget for the party. So if you manage to buy enough snacks without breaking your budget, you're solve a system of inequalities. So, system of linear inequalities, it is a set of two or more linear inequalities with the same variables. So the solution to a system of inequalities is often an infinite set of a points presented graphically or by shading. So first, what is graphing? So graphing is when you have a graph on multiple inequalities on the same group. The region where the shadings overlap is the solutions of the region, and you can see it in our graph. Two signs of graphing, as you can see it in our graph, if the inequality sign does have an equal sign, it is less than or equal to or a greater than or equal to, then draw a solid line. The second, as you can see in the graph, if the inequality sign does not have contain an equal sign, it is less than or greater than, then draw a dashed line.
Good day everybody, my name is Chimes Makaskas and I'm going to present the steps in solving of linear inequalities graphically. Here we have a sample problem of inequalities which are 5x minus 2y is less than or equal to 10 and 3x plus 2y is greater than 6. The first step that we're going to do is to solve the inequality for y and x. Let's do it first with the first inequality. First, let's find the y-intercept number by letting x become 0. So 5 times 0 is equals to 0. So because it's 0, it will be deleted immediately. Then the negative 2y and 10 divided by negative 2 to get rid of the negative 2 besides the y. Then 10 divided by negative 2 is equals to negative 5. So negative 5 is our y-intercept. Then we find the x-intercept, which then the y becomes 0. Then we do the computation. The same method will be applied to the second inequality like what is shown in the PowerPoint. Now that we have the y and x-intercept of the first inequality, now we're going to make a dot in the respective area where the y is equals to negative 5 and x is equal to 2 is located. Since the inequality sign contains equal signs, solid line will be used, just like the graph here. The next step is the shading part. We need to use the origin test to know where to shade. Let's test the first inequality by making x is equals to 0 and y is equals to 0. Compute all and we have this solution. 0 is less than or equal to 10, which means true. When it's true, the shaded part will be at the origin's location. The step 4 is where we locate the second inequality in the graph. Now that we have the second inequality, x and y-intercept, which are y is equals to 3 and x is equals to 2, we will locate them in the graph, which is like this. So, because the inequality sign is without equal, we're going to use dashed line, just like in the graph shown. To find where we can shade the second inequality, we will going to use the test origin again. Let x be 0 and y be 0, and then we will compute it. With the second inequality, 3x plus 2y is greater than 6. Like this. And so because it is false, the shaded part will be away from the origin. The last step is finding the overlapping region when you find it. That's the region that satisfies the solution. In this graph, the green part is where the inequalities overlap. And that's it.
Our topic today is exploring linear programming techniques from lesson 2. Theme: solving the intercept of linear programming and the objective function and its graphing solution. Objectives: to maximize or minimize a specific object function such as maximizing profit or minimizing cost given set of a constraint. To develop skill involving complex real-world problem involving resources allocation, production planning, transportation, or inventory management using linear programming techniques. Introduction. In real life, linear programming serves as a powerful tool for decision making in diverse scenarios, optimizing resources allocation and enhancing efficiency across various industry and everyday situations. Imagine a company aiming to optimize its profit by determining by the best production mix given limited resources. Linear programming enables them to allocate the available resources like labor, materials, and machinery efficiency among the different product or service, ensuring optimal profitability while meeting the production constraints. Linear programming or LP, also called linear optimization, is a method to achieve the best outcome such as maximum profit or lowest cost in a mathematical model. Most requirements are represented by linear relationship. Linear programming is a special case of mathematical programming, also known as a mathematical optimization.
In linear programming, constraints are restrictions or limitations on the decisions of variables that affect feasible solutions to an optimization problem. These constraints are expressed as linear equations or inequalities. The goal of linear programming is to find the values of the decision variables that optimize, maximize, or minimize a linear objective functions while satisfying the given constraints. The objective function of linear programming represents that you want to either maximize or minimize. It's a mathematical expression involving decision variables. The goal is to find the values of the decision variables that make this objective function as large for maximization or small for minimization as possible while still satisfying the given linear constraints. The objective function is usually informed in the linear equation. Third is linearity. The context of the linear program or mathematics in general refers to a relationship that is linear in a linear relationship. The output of directly or proportional to the input, and the superstition principle holds
good. Finiteness. There should be finite and infinite input and output numbers. In case of the functions as infinite factors, the optimal solution is not feasible. Non-negativity. The variable value should be positive or zero. It should not be a negative value. Non-negativity, especially being either positive or zero. Decisions variables. The decisions variable will be inside the output. It gives the alternate solutions of the problems. For any problems, the first step to identify decisions variable.
So in linear programming, there's a x, y, and z values. So in minimal value of z, so this is a z value, which is the objective function. Z equals 5x plus 3y. So the following constraints. So constraints is a limited of a graph function. So there are three constraints, which is x plus 2y is less than or equal to 14, 3x minus y is greater than or equal 0, and x minus y is less than or equal to 2. So in linear programming, how to solve it? So in constraints, you're gonna find an x-intercept and y-intercept. So if you want to find an x-intercept, so the y value is automatically 0. But the y-intercept, if you want to find the y-intercept, the x value is automatically 0. So you're gonna find it by divide or whatever operation you're gonna use to find the intercepts. And once you find the y and x intercept, you're gonna connect it through the Cartesian plane and draw a solid line because solid line is represented as the less than or equal to or greater than or equal to.